Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine a particle so small and so indifferent to the laws of solid matter that it can fly through a light year of lead without ever touching a single atom. These are neutrinos, often called ghost particles. They are born in the hearts of stars, in the violent collapse of supernovae, and in the mysterious accretion disks surrounding supermassive black holes. Right now, billions of them are streaming through your body every single second, yet you feel absolutely nothing. Because they have almost no mass and carry no electric charge, they simply do not interact with the world we know. To catch them, scientists had to get incredibly creative. They have built massive detectors in the frozen wastes of Antarctica and deep inside abandoned mines. But nature might have provided a superior solution in the most unlikely of places: the dark, crushing depths of the ocean floor, specifically within the alien environments of deep-sea brine pools. A brine pool is essentially an underwater lake. On the floor of the Gulf of Mexico, the Red Sea, and the Mediterranean, there are basins filled with water so salty and so dense that it does not mix with the surrounding ocean. These pools have their own shorelines, waves, and even distinct, often toxic, chemical signatures. But for a physicist, these pools are more than just geological oddities, they are high-density targets. To detect a neutrino, you need a vast volume of transparent, dense matter. When a neutrino happens to strike an atomic nucleus within a medium like water or ice, it produces a secondary particle, usually a muon, moving faster than the speed of light in that specific medium. This creates a beautiful, sonic boom-like flash of blue light known as Cherenkov radiation. So, why are brine pools the ultimate harvesting ground for these ghostly flashes? First, it comes down to density. Brine pools are significantly denser than standard seawater due to their extreme concentration of salts and minerals. Higher density means more atomic nuclei are packed into the same amount of space, which statistically increases the chances of a rare neutrino collision. While a traditional detector might wait days or weeks for a single clear event, the concentrated matter in a brine pool acts like a much more sensitive net for the passing cosmic ghosts. Secondly, there is the critical factor of depth and shielding. Neutrino detection is a game of extreme silence. On the surface of the Earth, we are constantly bombarded by cosmic rays that create a chaotic noise of background particles. This noise makes it nearly impossible to pick out the faint, singular signal of a neutrino. By utilizing brine pools located thousands of meters below the surface, scientists can use the entire mass of the ocean as a giant filter. The miles of overhead water absorb almost all other forms of radiation and interference, leaving only the nearly unstoppable neutrinos to reach the brine at the bottom. Furthermore, the unique chemical composition of these pools, often rich in heavy minerals like magnesium and potassium, can actually enhance the light-gathering process. Researchers are exploring whether these specific mineral concentrations could allow the brine to act as a natural scintillator, which is a material that glows when hit by charged particles. Instead of the massive expense of building a multi-billion-dollar tank of purified water and lowering it into the ground, we are looking at natural basins that have been chemically stable for thousands of years. These pools are essentially pre-made laboratories. The neutrino harvest represents a fascinating shift in how we view our planet's most extreme environments. Instead of seeing brine pools as mere, underwater graveyards, or hypersaline death traps for marine life, we are beginning to see them as windows into the deep cosmos. By placing strings of sensitive optical sensors into these pools, we can turn the bottom of the ocean into a massive planetary-scale telescope. This telescope doesn't look up at the sky. It looks through the Earth itself, catching neutrinos that have traveled from the furthest reaches of the universe, passing entirely through our planet before finally being stopped by the heavy salt of the abyss. As we continue to explore the deep sea, the intersection of marine biology, geology, and particle physics becomes increasingly blurred. We are finding that the keys to understanding the largest structures in the universe, galaxies and black holes, might be hidden in the smallest, most extreme corners of our own world. The deep-sea brine pool is no longer just a curiosity of the deep. It is a laboratory of the infinite. For more incredible facts like this, don't forget to subscribe and turn on notifications.